Now, when you push through the math behind this formulation, and the formulation behind something called the expected utility theory, which is the cornerstone of rational choice, it turns out that there are a number of what we call axioms that actually underlie this theory. I want to spend a few minutes going through these axioms one by one. The first axiom is something called completeness. It says something very simple. It says that if I give you the choice between x and y, you should be able to do one of three things. You should be able to choose x over y, or y over x, or you should be perfectly indifferent between the two. But you cannot say, gee, I don't know. Because the moment you say that, you are unable to compute a utility, and therefore you have no basis for making a choice. So, rational choice theory says people have the ability to maximize something called utility, and that completeness means they can either prefer x or y, or both equally. The second is perhaps one of the more important axioms of choice, and it is called transitivity. It seems fairly obvious, but let's think through this for a minute. Transitivity says if I like x over y, and I like y over z, I should like x over z. Makes perfect sense. If I'm going to give you $50 versus $100, you're going to choose 100. If I'm going to give you $100 versus $200, you're going to choose 200. If I give you 200 versus 50, you should choose 200. No arguments. But it turns out that there are many situations in which transitivity is violated. Here's one example. Let's imagine you're recruiting for a job. You're looking for an assistant, you're looking for a research assistant. 3 people apply, Mr. A, Mr. B, Mr. C. You've got information on 2 attributes, their IQ and the number of years of experience they have in doing that job. And what you see in this chart is that you've got 3 people with IQs of 120, 110, and 100. But the one who has the highest IQ has only 1 year's worth of experience, followed by 2, followed by 3. Now, you also know from all of your years of being a professor or being a researcher that, in fact, the IQ measure isn't very stable. And in fact, there's very little to choose between someone who has an IQ of 100 and 110 because the error on the scale is about 10 or 15 points. And so the idea is very simple, is you really can't tell the difference between 100 and 110, but you can tell the difference between 100 and 120. So here's my rule. I want to choose the smartest guy. But if they're equally smart, then I'm going to choose the one with the greater experience. How do I handle this choice? Again, I'm going to go look at A, B, and C. If I look at A versus B, A and B have about the same IQ. B has more experience than A. I'll choose B. Likewise, if I look at B versus C, about the same IQ. C has more experience than B. I choose C. So I choose B over A. I choose C over B. I should choose C over A. But if I had C and A in the same room, now I know that A is smarter than C, and I would pick A. Right? So that's a classic example of a situation where transitivity is violated. And the point is, sometimes, again, the context changes so that when you look at products in different pairs, they end up appearing differently attractive. There are 2 axioms that are more mathematical in nature, continuity and monotonicity. And I'm just going to skip them because their goal is to make sure that the mathematical consistency of the formula is maintained. But here's an important one, a axiom called substitution. And it says the following. If you are indifferent between 2 options, let's say an apple and an orange, you should be indifferent between a gamble, which has the same probabilities, but the same outcomes. For example, if I like an apple as much as I like an orange, and you came to me and said, Dilip, in option A, I'm going to toss a coin. If it is heads, you get an apple. Otherwise, nothing. Option B, I'm going to toss a coin. If it's heads, you get an orange. Otherwise, nothing. I should be indifferent between these 2 gambles. Now, again, this seems perfectly reasonable, but there are a number of situations in which this axiom is violated. And in fact, there are a lot of sort of follow-ups to this axiom. The idea of something called cancellation. Cancellation simply says, if I have 2 options which has the same identical feature across the 2, I should just cancel it out. It should be irrelevant to my decision. It turns out cancellation is violated in a number of situations. And perhaps one of the earliest demonstrations of the violation of cancellation was this example by Maurice Allais. It's called the Allais paradox. And what you see here is an example of a gamble. The one at the top says, I'm either going to give you option A, where I give you $1 million, no questions asked, or we're going to play a gamble. And if you play the gamble, there's a 10% chance of getting 2.5 million. There's an 89% chance of getting 1 million. There is a 10% chance of getting nothing. That's the box that you see up there. Now, it turns out most people would pick option A. If you're going to give me $1 million with no strings attached, that makes perfect sense. Here's a second example. And what you see here is now two gambles. Option A, 11% chance of $1 million, 89% chance of nothing. Option B, 10% chance of $2.5 million, and 90% chance of nothing. Now it turns out B is the more popular choice because the difference between 10%, 11% isn't that large. But boy, 2.5 million versus 1 million, that's a big difference. Here's the interesting thing. Those two boxes, those two problem sets were identical. What I did across the two was I simply canceled out the exact same equivalent across both options. In fact, what I did was I reduced the probability of winning $1 million by 89%. I simply canceled out those two from these two options. And what we've seen here is a violation of the axiom. Cancellation has been violated, and as a result, people's choices aren't rational, and they aren't rational because now the context has conspired to make option B look more attractive. So in sum, there are 4 C's that drive rationality, but as we go through this course, we'll see that there are many other facets of rationality that tend to get violated over time, and that's what makes human beings a fascinating set of people to study.